Hello, welcome to my channel. Today I want to explain the real solution to the twins paradox and why Einstein was wrong. Now I am aware that there are already many explanations and solutions to the twins paradox, but a lot of these explanations leave you confused even more after watching or hearing the explanation than before. And that's because a lot of these explanations are actually wrong. They complicate the situation even more, but run into the same paradox again. If you don't believe me, I encourage you to watch this video by Dialect called Why Solutions to the Twins Paradox. I'll straight along. I will leave the link of the video in the description, and also here's the video. So to begin, I want to explain what is the twins paradox. So what is the twins paradox? Okay, so imagine that there's object B on Earth, and object B leaving Earth and traveling in space at half the speed of light. Now, the twins paradox arises because of Einstein's special relativity and time dilation that occurs because of that. So, according to Einstein's special relativity, an object in motion will experience less time than an object stationary. So from B's perspective, A is in motion, so A will experience less time than B when he's going, and if he's coming back at half the speed of light again, then he will experience less time when coming back than B. And that means that when A goes and comes back, he'll be younger than B. But the problem is that from A's perspective, B is the one who's moving. So B will experience less time when going, because B is also moving at half the speed of light, so he'll experience less time when going, and experience less time when coming back. So B will be the one who's younger, by the same amount that B thinks they will be younger. And that's a problem, because who's actually younger? And this is the twins paradox. Who's younger, and why does each of them insist that the other is younger when the situation is symmetric from both perspectives? Okay. So now, I want to explain why the explanations, or the typical explanations of the twins paradox, are wrong. Okay? Okay. So now, I want to explain the typical explanations of the twins paradox. How they typically explain it, and how it's not a paradox. So first, we're going to have to use this formula, which is t dash is equal to t times root 1 minus v over c squared, where t dash is dilated time and t is equal to time of station object. This is a formula for time dilation, Einstein's formula for time dilation. So now, how they explain this is like this. If there's object B and object A in the same place as object B, and then he travels at some speed and returns back, object B is stationary and object A moves and comes back. Now imagine that A is moving at a speed that causes this part of the equation to be half, since there's only one variable here, B, C is constant, and this can be half. So the value A is moving at the value of the speed that causes this part to be half. So that means that when 1 second passes for B, half a second passes for A, or A experiences half the time that B experiences. So imagine A moved with this speed for 1 second in this direction and came back in 1 second. Imagine this second passed for B, so B experienced 2 seconds. So A moved this speed for 1 second from B's perspective. Okay, so now because B experienced 2 seconds, A will experience half the time, so experience 1 second. But B will think that but B knows that A will see B is the one who's moving. So B will say that A will calculate the time passing for B to be half a second, because 1 second passed for A, so half a second passed for B. So which is correct? 2 seconds passed for B, which is what B thinks, Or did half a second pass for B, which is what B thinks A thinks that B experienced? Yeah. So now the explanation is that A will agree somehow that that B experienced 2 seconds instead of half a second, and that's by having B agreeing that he's the one who accelerated here, because apparently acceleration is not relative, which it should be relative, but okay. So when A decelerated, B didn't decelerate from A's perspective. So A is the one who decelerated. So when A decelerated, he skipped over, and this is the explanation, he skipped over the remaining time, which is um, 3 over 2 of a second, because half plus 3 over 2, which is equal to, so he skipped over 3 over 2 of a second. So when 1 second passed for A, when he's going and returning, in his perspective, B went and returned, and only half a second. But because A agrees that he decelerated in this time instead of B, then during this deceleration, the 3 over 2 of a second passed for B but didn't pass for A. So actually, B experienced 2 seconds from A's perspective. That means that from B's perspective, B experienced 2 seconds, and from A's perspective, also B experienced 2 seconds. And from both perspectives, A only experienced 1 second, and that's how they explain the twins paradox. Now, here's the problem. Imagine if instead of A moving for 1 second, he moved for 2 seconds. Okay? Oh man. Accidentally opened internet. Okay, so okay, if A moved for 2 seconds instead of 1 with the speed and then returned back for 2 seconds, B will experience 4 seconds. A will experience 2 seconds this time, because for this equation, using this equation, A will experience half the time, and A will think that B experienced half of that, which is 1 second. Now here, this time, during the acceleration, A will, during the deceleration or the acceleration period, A will skip over 3 seconds instead of 3 over 2. Okay, and that means even though the same exact deceleration happened, but from this speed, the same speed that he was going on, in this situation, A was moving the exact same speed, he only moved for a longer amount of time, and then decreased from that speed to the same speed in the opposite direction. So he did the same deceleration, but he skipped over a longer period of time. So the same thing happens, but he skipped over more period of time, which doesn't make sense. It only makes sense if somehow object A tracks since the last time he accelerated how much time has passed. Somehow. Which would be really weird. Even though the same exact acceleration happens, or deceleration, still a different amount of times can pass depending on how much time you spend before the previous acceleration. So here's why I think the explanations of the twins paradox are still wrong. Okay. Now I want to go over special relativity, Einstein's special relativity. Like relook at it and how he proved it and stuff like that. Okay, so now we're gonna look at Einstein's time dilation. And this Word document by Yassein Dahshan, which is me. So first, why does Einstein think there is time dilation? Well, it's because of these two postulates. Just these two postulates, which the first is all inertial reference frames are identical. All physics is the same in all those reference frames, which basically means that whatever speed you're moving at, the physics will be the same as if you're stationary. So from your perspective, if you're stationary, physics will still be the same. And the second postulate is that the speed of light is constant in all inertial reference frames, which means it doesn't matter what speed you're moving at, the speed of light will still be the same as if you're stationary. Okay? So what can we conclude from these two postulates? Well, imagine that there is an object A and object B, again, and light is passing to the front by these two objects. Relative to object A, object B is moving at 5 meters per second. So, relative to object A, object B is moving at 5 meters per second. And imagine that relative to object A, light is moving 10 meters per second. So imagine that the speed of light is 10 meters per second, not the speed that we know. Now, because B is traveling at 5 meters per second, it should see the light moving at 5 meters per second instead of 10. Because each second the light moves 10 meters and B moves 5 meters relative to A, so B should see the light moving at 5 meters. So each second is relative to 5 meters. So B would see the light passing slower than how A sees the light. B would see the light passing slower than how A sees the light. But wait, light should move at the same speed for all reference frames, according to our postulates. So the only way that light would still pass at 10 meters per second, not 5 meters per second for B, is that when light moved 10 meters in 1 second relative to A, and moved 5 meters relative to B, that only half a second would have passed for B. So that when you divide 5 over 10, you get 10 again. So according to these two postulates, Einstein concluded that when you move faster, time goes slower. Now before we go any further, let's try the formula for that. The formula would be, when an object B is moving at x ratio of the speed of light relative to A, then the time passing for B compared to the time passing for A would be represented by time passing for B equals 1 minus this ratio times time passing for A, where time passing for A is time passing for A and time. Okay. Let's see the formula. Let's see if the formula works. For example, if B is moving at 1 over 4 of the speed of light relative to A, and the speed of light is 10 meters, so the same situation but half, but 1 over 4 instead of half, so B would be moving 2.5, 1 over 4 of 10. So then, because B is moving at 1 over 4 speed of light, in 1 second passes for A, light will travel 10 meters relative to A, but only 7.5 meters relative to B, because B would move 2.5 meters, light would move 10, so only 7.5 meters. B would see the light only moving 7.5 meters. But how do we get 7.5 meters? Well, it's 10 minus 2.5. Yeah, that's what we did. And it is 10 minus 1 over 4 of 10. Because we want to do it just in terms of these two numbers. Where 1 over 4 is the speed of B over the speed of light. Yeah? Because light moved only 7.5 meters for B, then it should move this amount of meters in only 7.5 over 10 seconds, so the light would still move at 10 meters per second for B. Okay, because 7.5 is the same as 10 minus 1 over 4 over 10. Yeah, that's what we did here. 7.5. How do you get 7.5? It's 10 minus 1 over 4 over 10. Where 1 over 4 is the speed of B over the speed of light. And then 7.5 over 10 instead of 7.5 is the same as all of this, which is the same as 7.5 over 10. If we simplify, we get 10 will cancel with 10 with 10. We get 1 minus 1 over 4 seconds. So, because 75 over 10 seconds pass for B, the amount of seconds that will pass for B is 1 minus 1 over 4, which is the same thing. Pass for B in 1 second, but now it's in terms of 1 over 4, which is the ratio instead of just random numbers, okay? Then 1 over 4, so then 1 over minus 1 over 4 seconds, 1 over minus 1 over 4 seconds times time, yeah, when 1 second passes for B, this will pass for B when 1 second passes for A. This amount of time will pass for B when 1 second passes for A. So when 80 seconds pass for A, then 80 times this amount of seconds will pass for B. So when 1 over 4 is any ratio of the speed of B, so if you have, instead of this situation, another ratio instead of 1 over 4 over the speed of light is in ratio x instead of 1 over 4, then the formula would be 1 over x times AFT. So the amount of time passing for B, which is the moving object, will be 1 minus x times 1 over time passing for A. Now I don't know that this is not the same formula that Einstein used, but this is still a correct formula according to the postulates, and I will show later why Einstein got a different formula. First, let's see some problems we will face. First, if there is light moving in the opposite direction. So, okay, so you have two lights, light moving in this direction and light moving in this direction, light L. Both of them are moving at 10 meters per second, because that's the speed of light. That's what we're imagining right now. Okay. Compared to light L, we use the formula compared to this light, which is the same as in the previous situation. BT is equal to 1 minus x times 80. Time passing for B will be 1 minus x times 1 minus A, where x is 2 and 5 over 10, which is 1 over 4. But compared to light M, when 1 second passes for A, light moves 10 meters left. But because B is moving right at 1 over 4 of the speed of light, which is negative 1 over 4, so if we plug in negative 1 over 4 instead of 1 over 4, so because the ratio is negative, if you have a negative ratio here, you get the formula, which is, the formula would be 1 minus 1 over 4, which is 1 plus 1 over 4. And that is because this time B will see light moving at 10 plus 2.5 meters. So yeah, 10 light B, B will see the light moving 10 meters and also 2.5 meters because he's not moving in the opposite direction. So you see light moving more distance. And now, then when the light moves and mounts distance, it has to move this amount of distance in 1 plus 1 over 4 seconds for B, so that the speed of light is still 10 meters per second to B. So the formula compared to light M is B of t is equal to 1 plus x, where x is just the ratio of the speed of B instead of the speed of A, times A instead of this, where x is equal to any speed of B over the speed of light. Yeah, so in terms of this light, it's 1 plus B plus the speed of B. In terms of light L, it's 1 minus x, or 1 minus 2.5. Okay. But this means that when, for example, 1 second passes for A, 1 minus x seconds passes for B compared to light L, but compared to light M, 1 minus plus x seconds passes for B, when 1 second passes for A. So if x is equal to 1 over 4, when 1 second passes for A, compared to light L, only 3, so if x is equal to 1 over 4, and 1 second passes for A, then the time passing for B is equal to 1 minus 1 over 4, which is 3 over 4 seconds. But compared to light M, it will be 1 plus 1 over x seconds, so 5 over 4 seconds pass for B. But how can this be? Yeah, it's a joke. Did 3 over 4 seconds pass for B? Did it 5 over 4 seconds pass for B when 1 second pass for A? Because, compared to different lights, different amount of time will pass for B. If we choose a light passing at an angle instead of these two lights to compare the time to, we would get even a different time passing for B when 1 second passes for A. So this is a big problem. Now this is the same reason why Einstein's formula is different from my formula. That's because he used light moving at an angle, so we got a different formula. So how do we solve this problem? There's only one way to solve this problem, which is one of the postulates is incorrect because you can't have 2 times passing for B. Instead of, like, when 1 second passes for A, there only has to be 1 time passing for B, not multiple. That means that 5 over 4 is equal to 3 over 4 somehow. Okay, so before that, let's see how Einstein made his formula. Well, like I said, he used light moving in an angle to compare time to. He made this thought experiment. Most of you probably are aware of it. So there is a train. Okay, this thought experiment, he said there is a train moving it, and A is the train's reference frame. A is in the train's reference frame, so A is moving with the train, and B is the reference frame of the track, so B is outside, not moving with the train. A is moving at speed u relative to B. A is moving at some speed u relative to B. And light's moving up and down inside the train from a mirror. Light's moving up and down. So change from the mirror on the bottom to the one on the top relative to A. Yes, it's moving outside. But from the outside, since the train is moving to the right, the light is following the diagonal path. Light is following the diagonal path from outside. Because as the light reaches the mirror on top, the train would have moved forward. Yeah, that's why it's moving track. So from outside, light moved both up and forward before reaching the mirror on top. So the light moved diagonally. So since the speed of light is the same for both reference frames, supposedly, and because the two reference frames will see the light moving different distances before reaching the mirrors. Yeah, because B will see the light moving different distance as this, because it's different than this distance before reaching the mirrors. Then time must have passed differently for both of them. First, let's simplify this experiment. It's a simple one which gives the same results. So here, instead of light going diagonally up and diagonally down, it goes only diagonally up, which will not change the distance it travels. Still, when A travels this distance, light still double this distance. When A travels double the distance, light will travel double the distance, instead of traveling here and then traveling down, which is the same distance. So it will not change anything. And the y component of the light is the y component of light is the speed at which A sees light moving with. Yeah. So B is outside, stationary. A is moving at c of x, which is the y component, the x component of the speed of light. So A is moving at the x component of the speed of light. The speed of light is moving diagonally, and A will see the light moving at this speed because when the light moves, its x component is the same as the distance that A travels, or the speed that A travels with. So A will see the light moving with this speed, only the y component of the speed of light. So it is straight up instead of up and then down. So that's the difference between situations. Light will be traveling only up instead of up and then down, but it's still the same speed. So it's straight up, yeah. So to understand the distance that AC is light travels, and A is moving with speed u, which you can measure, and light is moving at an angle such that the x components of its velocity, c, is equal to the speed of A relative to B. So yeah. A will see the light only moving up with y component of c. So if 1 second passes for B, we say that the speed of light is, for example, 10 meters per second. Again, when 1 second passes for B, light will travel 10 meters. It will travel 10 meters like this, because speed c is 10 meters per second, imagine that. And if the x component of the speed of light is 10 meters per second, and if the x component of the speed of light which is 10 meters per second, is u meters per second. So the x component is u meters per second. Then y component would be root 10 squared minus c squared. That's the y component using Pythagorean theorem. So in 1 second passes for b, light will move c distance. So in 1 second passes for b, y component of c, the y component of c would travel a distance of this. Yeah, so when 1 second passes for b, the y component the y component will travel a distance of 1 times that, 1 times root 10 minus u squared, because when 1 second passes for b, the light will travel c distance. The y component of this distance is root 1 minus the x component of this distance, which is u, because a will travel at u speed and y is moving such that the x component is the same as the speed of a. So that means that this is the distance that the y component will travel. But since a has to move, c has to see the y component traveling at the speed of light, a has to see this y component traveling at the speed of light, because a only sees the speed of light moving at y with this y component, which is 10 meters per second. Then only root 10 squared minus u, which is distance traveled, over 10 seconds would pass, because this is the distance. So if we divide by this, so if we divide this by this will cancel this and 10 will go up, so it will be 10 seconds. So this is the amount of seconds that have to pass. That pass for a, so that a still sees light of light traveling 10 meters. And that's because if you divide this by this, you get 10 meters per second speed. So if the light is c instead of 10, yeah, you get then you get c squared minus u squared over c squared seconds would pass for a when 1 second passes for b. This can be simplified to 1 minus u squared over c squared seconds passing for a when 1 second passes b. Yeah, because if you simplify this, you get this basically. Pass for b. Okay. Let's write this passing for a when 1 second passes. When t seconds pass for b, this amount of seconds pass for a. This times t. So if t dash is the time passing for a, then t dash is equal to this times t, which is Einstein's formula, which is what Einstein's formula looks like. But okay, you can see from the diagram that when speed of a increases, that the angle of light we are measuring the time of a changes, so that the x component of the light matches the increased speed of a. The problem with this method is that it only measures time of a compared to only one light angle, which is the angle that has an x component matching the speed of a. This angle actually changes. This angle changes depending on the speed. This formula gives you not a specific angle, but an angle that will call that. Yeah. So it measures the time passing for b compared to a light that has an angle which the x component of is the same as the speed of a. So according to Einstein's, light traveling at this angle is the only light that remains at constant speed no matter your reference frame, but at any other angle, the light speed would change from one reference frame to any other. Yeah, so according to Einstein, if you're moving, according to this formula, if you're moving, this is the only important angle of light. It's like the angle that has the x component the same as the speed of the object, and any other angle would be different, because if you, as you see, it's seen in the example above, if you have another angle of light at when you have some speed, then this other angle will give you a different time for a. So this is the only angle where light would be traveling Yeah, this is the only angle of light would be traveling at the speed of light. Actually, any other light traveling any other angle will not be traveling at the speed of light from both perspectives. This is according to this formula. But obviously, this is not what the postulate says. Postulate says that light is constant in all frames of reference. It doesn't matter the angle. So which postulate is wrong? Because the postulate of all inertial frames of reference are identical, must be true. Because the postulate that all frames of reference are identical must be true. Then the only remaining option is that the postulate light being constant to all frames of reference must be wrong. So light cannot be constant in all frames of reference. In conclusion, Einstein time dilation is wrong. Just use a complicated experiment to derive a fancy formula based on the wrong assumption so that people would believe him without showing any proof of his assumption. His assumption is that light is constant in all frames of reference. He assumes that light is constant in all frames of reference and built his formula based on that without considering all possibilities, and didn't prove that his light is actually constant for all frames of reference. But because there are different possibilities that would provide a different result, that would contradict the results from his formula, then the assumptions he makes must be false, because if his assumption was true, there would have been no contradiction. Okay. So basically this means that time dilation cannot be true, because at different angles of light, you would have different times for objects A and objects different times passing for the moving object at different angles of light compared to different angles of light, because at different angles of light each object will see this different angle of light to be traveling differently. And so you can probably see where I'm going with this. So that means that this is the solution to the twins paradox, is that actually time dilation is not correct, so the twins paradox will not exist.